Okay, so looking at this problem, let's understand what's being asked. So first of all, you have these two hallways. One is of length B, and then the other one is of length A, or width A. They meet at this right angle over here, and we want to know what the longest ladder is. So in green is this ladder. Now, the angle that it makes with this here is going to be theta, and you should also see that if I draw this line here, that's also going to be theta. These two angles will be equal. We want to know what is the longest ladder that can actually be navigated around this corner here. The thing is that we should see that theta, right, it's going to start off at 0 when the ladder is like this, let's say. Then it's going to increase till it's in the position it's in, and then it's going to eventually turn over. You want to sit here and you want to ask yourself, what is the longest ladder at any theta? Okay, so longest, let's come up with a function for longest ladder at theta. Okay, and I'm going to abbreviate that longest ladder of theta. We should see that it's going to be whatever this length is, m over here, plus n. So I'm going to write that as m plus n. M plus n. And then I'm going to come up with expressions for what m and n are. Now, before we do that, let's just take a step back. Let's go back. I'm looking for the longest ladder at any theta. Okay, and what do I want to do with this function at the end of the day? Well, I actually want to minimize this function. Why? At any point, right, so I have to take some ladder and rotate it through 0 degrees, right, theta, or 0 in radians to pi over 2, right? So the ladder has to be able to go from 0 to pi over 2 in its radians, right, as I turn this ladder, as I navigate this around the 90 degrees, or from 0 to 90 degrees. At any point, if the ladder is longer than the longest possible ladder for any of those angles, then that ladder is too long. So the longest ladder at theta is the longest ladder that I can navigate around the corner. And that's the trickiest part about this, maybe, or at least conceptually, seeing that you want to minimize this function, right? You want to minimize this function here. Okay, and again, let's get this function now. Longest ladder at theta is m plus n. Now, what is m? Well, if we look at m in this one, right, you take out this triangle. So I take out this triangle. Here's theta. Here's m. And then this length is a, right, that bottom length. So what is it? Cosine of theta is a over m. And if you solve for m, you're going to get cosine theta over a. Or, sorry, you're going to get a over cosine theta. You're going to get a over cosine theta. And similarly, if we look at this length is b. So if we look at this triangle, right, this is b, this is n, this is theta. So it's sine theta is equal to b over n. And then when you solve it for n, you get b over sine theta. And I substitute these values in here. I get a over cosine theta plus b. M is a over, yes, and n is b over sine theta. Now, again, you want to minimize this function. The way we're going to minimize this function is that we are going to take the derivative. So the derivative of this function is what? Well, this we could look at as a cosine theta to the -1 plus b sine theta to the -1. And I'm going to do a bit of chain rule. I'm going to say negative a cosine theta to the -2 times the derivative of cosine theta is negative sine theta plus this is going to be negative b sine theta to the -2 times the derivative of sine theta is just cosine theta. And I'm going to do some simplification here. This is going to be a over a sine theta over cosine squared theta minus b cosine theta over sine squared theta. Now this is my derivative, and what do I typically want to do? I want to set it equal to 0, because where I find out it's going to be equal to 0 is where it is that I could have a min of this function, because I'm looking to minimize. So I set this derivative equal to 0. 0 is equal to a sine theta cosine squared theta minus b cosine theta over sine squared theta. And I solve. When I solve, okay, what I'm gonna get is that theta will be equal to tan inverse of the cube root of b over a. Now, to find out, if you sit here, again, just sit here and do this algebra, it'll take some time, move this over, get it so it's in, the right form, and then you're gonna have to take the cube root. You're gonna have to do tan inverse, because it's gonna be a tan, tan to the third. You're gonna take the cube root to get tan, right? And then you do tan inverse on both sides to get what theta is. Now, it's not nice looking at it like this, especially since this is gonna be the value that minimizes theta, and you could actually convince yourself that it will be a minimum, because you see, if you start off with, or better yet, you can convince that it's a minimum using this, right? So, here's, let's say, your angle. It starts off at 0, and then it's going to go to pi over 2, right? This value is somewhere in between. Now, if you start off with 0, you should see that the derivative is going to be undefined. So you pick a value that's just to the left, and you can actually conclude that this is a minimum. Now, if you want to plug it in, I would say just actually draw the triangle. You don't want to sit here and do this crazy nonsense. What you would say is that tan of theta is equal to the cube root of b over a, which is the same thing. Tan of theta is equal to the cube root of b over the cube root of a. If I did this all okay, let's see, did I do this all okay? Let's see. Yeah, I believe I did. Okay, so then now, since that's the case, theta is right here. Tan is opposite, which is the cube root of b over the adjacent, which is the cube root of a. And then you get this. You use this fact to solve for the hypotenuse, and then you could say, well, what is the actual value? You just find out what sine and cosine are. So what do I mean by this? So let's see. This is going to be, and we got to be careful with the algebra, it's going to be the square root of, it's going to be the square root of a to the 2/3 plus b to the 2/3. And then what we do is if we're looking for what the longest ladder is, theta in this case is, remember, this angle theta that we're going to call whatever, theta, I don't know, theta dot at the bottom. This is theta dot, right? This particular value of theta when tan inverse, tan inverse of the theta value that gives you the cube root of b over the cube root of a. So then what you have here is this, and then what is it going to be? Well, it's a over cosine of this theta value. So cosine of this theta value is the cube root of a over the square root of a to the 2/3 plus b to the 2/3. Okay, and you would do some algebra here, plus, and so forth and so forth. And you would use this triangle here, would be the key thing. But this is the general idea.